presentation. Dr. Duda flew in from New York.
Well, I flew from Baltimore this morning.
But he's making a tour. He's doing here in Tampa. Tomorrow he's doing a lecture in Orlando. And then after that, on Wednesday, he's flying Jamaica and he's doing a lecture in Jamaica.
Yeah, that's where to go.
I see
Yeah.
him in Jamaica. Sign up now.
Then Thursday I'm moving out of New Jersey. I have to. My wife will be waiting for me. Arrive JFK, then I go to. First started providing the LTE service, and most of the countries now still have LTE. Some cases like 3G, so called back 3G and 4G. And now we are around 2020. We are hoping we'll have 5G, right? People have still started providing the fixed access, right? They still do not have the mobile access yet. So that's kind of a real evolution. So every 10 years has been a new generation, and hopefully by 2030 you will have 6G, right? That's a guess. So that's what people are thinking, right? So they started doing the research. So the other thing is, in the standards, again, this is a chart from Gerhard, we all know what Wi-Fi, right? You also know cellular. So this is an interesting thing, in IEEE 802, we have been developing Wi-Fi standards. At the same time, this is 3GPP, like GSM, GPRS, 3G, this the chart I showed before, right? So these two camps are going hand in hand. And today, they do coexist, right? It's not like, if you are going to a hotspot, you switch back to Wi-Fi, move away, and then go to your car, you change to 3G, right? So what you're seeing on the left, on the y-axis is the actual bandwidth, and they are progressing together hand in hand. So when we are going to do any research or anything, we still have to look at both, like cellular, at the same time the enterprise. So Wi-Fi is the enterprise. But then also Wi-Fi 6 now, where Dorothy Stanley, she was the chairperson, she gave a talk last week, and so the Wi-Fi 6 is already available, right? So many places people can use Wi-Fi 6, obviously with different bandwidth, like sub 6 gigahertz. But so the important part is they all have to exist together, right? So any application we provide or design, we have to think about both. So now how 5G is different? Let's get into a little bit of the actual characteristics. So again, 5G is an ecosystem. That's one of the reasons IEEE started this Future Network initiative, because you really have to change things bottom up. It is not only designing a new network, protocol, or communication system. You got to design new antenna. You got to design new chipset. There are a lot of interesting use cases with spectrum sharing. There are different kinds of bands like sub 6 gigahertz, millimeter wave, like 28, 39. There's massive MIMO, beam per wing, right? So these are all the physical layer characteristics. Then you have multi-radio access handover, right? Wi-Fi, 3G, 4G, 5G. The interesting part is a lot of device-to-device communication. Right? It's not only human to device, human to human, but lots of industrial automation will also take place. The other thing is the densification of small cells. If you look at the millimeter wave, it's very similar to Wi-Fi. You're probably going to see a lot of, again, depending on which bandwidth you're working on, if it's 28, 39 gigahertz, you're going to have lots of cells. And there's a deployment nightmare too, because you get a lot of bandwidth, but you have ranges too low, right? Then you have the wireless backhaul access, like all the fiber can be replaced using millimeter wave, like Horizon has Pios, right? You may not need Pios. So you can have millimeter wave as your backhaul. Context and networking, network might be moving around. The thing I circled, or I put a square there, was integration flexible networks, because this is what I'm going to focus on. Your networks is going to be flexible. A mobility, simultaneous mobility, people are moving around at a high rate, how you can support the continuity, right? So those are the important things. So if you see, those are the main ingredients which are a little different than other traditional 3G, 4G. Let's focus on how the network may look like, right? So this specific one, I'm showing a very high-level picture of a 5G network, and So there are three things here. One is your resources function level. You have a lot of programmable networks like edge cloud. You have a core network, user control, separation. Then you have things like slicing. So I'll talk about slicing a little bit. Slicing is, think about like a physical network, and you create multiple slices and assign resources to each of the slices. If you have a priority service, it's like HOV LAN, think about like a LAN, right? Like HOV LAN has obviously high priority and things like that. So end to end, you can slice and assign CPU, memory, disk storage, all those, and create a chain and call like end-to-end slicing, and use that just to support priority services, for example, right? If you have best effort service, provide a different slice, and you can share resources among those slices. So in a way, it's like almost like a statistical multiplexing. You're not really vesting the resources, right? So that's the slicing part. And then you have the programmable controller, like software-defined controller, user plane control plane separation. So if I try to start the animation, so you have the 5G new radio, which is fiber like components. Network function virtualization means, I have a slide later on, but if you look at the routers, switches, the traditional, if you walk into any machine room, right? I used to work for Columbia University back in 1990, and the big Cisco boxes, Juniper, all those, and now they're all going to be cost-based, right? So all software. So you have Linux operating system, OpenStack, Dell or HP hardware. Then you put all the software modules, right? Software routers. So it's going. So we call it network function virtualization because the whole network function, routing, switching, firewall, everything is going to be virtualized. So you can have multiple VNFs. In a way, you are cloudifying the whole network, right? That's the whole idea. And it will happen all across RAN, cloud, and application. And then you have the programmable network. The whole OSS is going to change. So you have an orchestrator, you have an SDN controller, you have a data analytics, then you have all these network resources. Something happened in the network, orchestrator knows that, it tells the SDN controller, and it goes, spins up new VNFs, adds rules on demand, things like that. So this is a whole like a closed loop system, and how quickly you reconfigure your network, right? So when I said the whole RAN, radio access network, core, transport, everything is going to be programmable. And the last one is the slicing, that's what I was saying. So you have, when you are having a service, right, you have a RAN, you have a core, you have application, and each of the network component can be sliced to support different kinds of services. So you can have maybe 5 different slices going to the same router, but let's say it's 70% of the CPU provide to the priority service, 10% to file transfer, 15% to something else, right? So you can just chant them, and then you just slicing manager to assign the resources on the fly, right? So that's almost like a virtual network, right, on top of the network. So that is a very high level view of how 5G, the network centric view, right? Now you might be wondering, so how is different than actual 4G in an architecture level? So if you see the 4G is over there, right? You have a user plane, the serving gateway, BDN gateway, you have the control plane. Now we are moving away from that. This is how the 5G is going to look like. 5G, the internal architecture. So you still have the user plane. On the other side, the data plane and control plane got separated. There are a lot of protocols like Diameter, SS7, had security problem. Diameter also had security problem. So we are moving towards like service-oriented approach. So like a publish, subscribe. So you have this data plane. You subscribe to a certain function. Something is available. You can get notification, right? So it is all HTTP REST API based. No Diameter protocol anymore. So it is a service-oriented approach we are taking, moving away from evil packet code, which is the LTE. But this may not happen overnight, right? People already have AT&T, Verizon, Sprint, all these operators around the world. They still have the EPC. So you cannot just uproot it. It's not like a Y2K problem, right? So you have to have a transition to move. And how people are doing that? So if you look at it, in 3GPP, they call it options, different options of transition. So where are we today? We are with option 1, right, which is LTE. The LTE E node B, which is the RAN, ePort packet core, which is the the core network. Now, if we have 5G today, it will look like this, right? Option 2. So new radio, which is the 5G radio, and 5G core. So, but we don't have the 5G core today. It's still evolving. So if operators, they have to start providing service, they have to coexist. So what they're doing right now is option 3, which is you still have the evolved packet core, which is the 4G core network. You have LTE node B, right, which you're using, and 5G new radio is already ready. That's the radio side. So that is the option we are now people are providing. Most of the operators are providing. So they call it non-standalone. That's called non-standalone. And option 2 is standalone. That means you don't have to worry about LTE. So a new operator comes 3 years from now, they may not have to deal with 4G anymore. They can directly jump into option 2, right? So this is how, and these are other options, right? In some cases, you may have a 5G core, like interoperable between new radio, which is 5G new radio, and enhanced LTE, right? But right now, people are focusing on option 3. After option 3, they'll probably go to option 2. So that is how that transition, it makes sense. So with that, jump in now. So again, I'm just trying to rehash this. So 5G is not only massive bandwidth or massive content, which has been mostly, the previous Gs. It has massive IoT, massive control, and massive resiliency. So that's where this whole SDN and NFV comes. And on the left-hand side, what I'm showing is the types of application that fall into this category, right? Remember the first 2 slides I showed? So you can take the SLAs and try to put them in this category. On the network operation side, then the slicing, routing, over internet, or some kind of impersonation of voice over IP. Somebody stole my call, it looks like my dad is calling, actually somebody else, right? So you need to be able to detect that on the edge, right? Because your call is coming through the node B, going through equal packet core, coming here. So ideally today, people are detecting it right here. But by doing that, you're already a lot of bandwidth resources are getting invested there. So that's for the edge security. Now people are thinking of putting things on the RAN or the MME, so it detects it before it even hits the application servers, right? So for this also we did the same thing. We tried to come up with articulate the types of threats. So the second and third column remain same, but on the fourth column, because it is a different protocol, different part of the network, your attacker will do different way, right? Because the protocols are different. So you can do a spam over internet telephony. You can change your RTP stream. You can do a lot of bad stuff on the diameter, right? So these are the kind of things, and then you come up with your mitigation technique. So what else is left now? The RAN, right? So I talked about equal packet core, IMS, and the RAN side. So on the RAN side, obviously there are not many interfaces, but think about it. If you're 5G, you're going to have a lot of these G node Bs, and so there are potential physical attack or access to those G node Bs. And then you have the data plane, which is the serving gateway. You have operation, administration, maintenance, the element management system. Then you have S1 MME, which is the control, right? So you potentially, because this remains somewhere in the field, right? Then you have the whole backhaul network. And in some cases, small cells, you have to have IPsec encrypted. So you really need to make sure these components and the communication is really protected. Even Fastnet, for example, right? They're doing this S1U encryption that still hasn't happened.
And I'm sorry, what does RAN stand for? One more
The
time?
radio access network.
Radio access.
Radio access. So basically, all the cell towers. So from the radio access, this is my, let's say, AT&T's core network or Verizon's core network, right? So they have their own backhaul, And this backhaul right now is fiber. It could eventually be a 5G millimeter wave. So for the RAN also, we did the same thing. Same thing, but over here, your description is different. This is one example. Control the network. So attackers control the E node B or implementation flow. They can put a rogue E node B and hijack your traffic, right? So that's another interesting example. I'll share the slides so that you can have it. So what I was trying to tell you is these are the ways you can analyze this existing network. And now if I so now if I go back and try to what I learned from here, right? So when I'm designing a new network, I have some existing threads, right, which I'm showing in orange color, and there are new virtualization threads, and there are also opportunities, and which I'll talk about the opportunities later with use cases. So you have to really put that together and see how the new security landscape is going to look like. So let me now give some example of use cases here, right? So first use case, talking about the opportunities. So this is an opportunity because we are adding resiliency. Think about there's an attack happening, and in traditional way, let's say MME, because this is a single plane, right? The MME gets overwhelmed, and I have to go and add new MME. So here, in this case, orchestration gets the notice that MME is getting overwhelmed through the analytics, and keeps up spinning up new MMEs. So you can keep on adding additional MMEs, the mobility management entity, right? While you figure out who is attacking it. So they call it recover fast, resolve next. That means you got to make sure the service is not interrupted. Then you figure out who is doing it, right? So that is an opportunity, the security opportunity of the resilience. The second opportunity is, as I said before, if there is an attack happening or malware, like somebody sending a malware on my data plane, so my customers will be affected because they'll get infected with malware. So you see that SDN controller, right? So somebody detects that, gets it back to the SDN controller. The SDN controller knows this is the IP address, IMEI, location of the attacker, and where it is going, right? So then it goes, reconfigures the firewall rules on the fly, right? The example I was telling. So you very quickly you detect and mitigate the attack. So this is through SDN control, this is an opportunity, right? What is the challenge? I just gave two examples of opportunity. So this is another challenge. So remember the hypervisor threat I was talking about? So this is my hypervisor. I have different virtual network functions. Remember those LME, PGW, SCW, and they could belong to different customers, like tenants, right? So if this gets compromised, one VM gets compromised, it can attack another VM. So this is a challenge, potential challenge, right? And so I need to make sure, while hypervisor is providing us a lot of opportunity in terms of having multiple machines, I have to have proper security hardening mechanism to detect and protect the system. So this is a challenge. So another challenge is DNS. SDN controller, sorry. So this is what I talked about, right? So because SDN controller is the heart of changing different things, so these are the types of security attacks that you can have. So northbound API, southbound API, sometimes it is open source, you need to make sure there is no bugs, nothing like that.
And what is ODL?
Open Daylight. So Open Daylight is a, remember I talked about open source? So there are lots of open source projects where they give it out to the community. So let's say Cisco has started that. So this is where advantage of using open source, but sometimes in this example there was a bug, external XML entity attack. So because of that, hacker was going in and changing the configuration, which is not good. So this is a security vulnerability or a challenge, right? The next one is DNS attacks. So everybody knows domain name system, right? DNS. And this, I personally had experience with this. So you have the virtual DNS in an operator network, and sometimes the hacker uses DNS reflection attack, uses somebody else, gets into that, and sends lots of bogus queries, right? So when the bogus queries goes, the replies goes back to the victim with lots of big bytes. So your virtual DNS gets overwhelmed, your firewall, which is here, that gets overwhelmed. Obviously, victim is affected anyway. So in this case, what happens is you see the DNS is getting overwhelmed, you keep on adding additional virtual DNS servers. But if you do that, that's actually amplifying the whole reflection attack, right? So that is something you have to keep in mind. You just don't keep on just adding different resources. At the same time, figure out who is doing it, right? So again, this attack is coming from the internet side. The other attacks are just coming from the subscriber side, right? So this is another, so you're providing elasticity function, but the amplification attack gets amplified, right? So you have to, this is a challenge. All right, so I think I talked about that. Let me just directly go into some of the 5G things that we can wrap it up. So now I talked about the telecom, that the whole piece I was talking about, I took telecom as a use case. Now, if you have to do the same thing for enterprise networks, you have to do something very similar, right? So what I'm showing here is a data center 1, data center 2. And there are traffic going within the data center from different VMs, the same host or different hosts. We call it east-west traffic. Traffic is going from one data center to another data center, we call it north-south traffic. So in this example, I'm showing again for an enterprise traffic, you don't see those LTE, EPC, all the RAN stuff, right? This is all core stuff. So your attack can come from different ways. So first one, attack from the VMs, the virtual machines in the same domain. Attack to the host, hypervisor, and VM from the application. So you have the host, right? The host application, but there are also VMs, right? So host application can also attack. Attack from the external communicating third party. So third party, you're communicating might get attacked there. Then remote management from the edge network, right? Some of the attack may come from there. Or if you're having one data center, another data center, so there are potential source of attacks there also. And now if you analyze that, and I have slides to talk about each of those threads in a, I don't want to explain it now, I don't have time, but these are the kind of attacks I showed and how it happens, why it happens, right? Just like it did for telecom network. So these are all different 7 threads I talked about, okay? Now, then how to approach a problem then, right? So let's say there is a security, this one example is hypervisor, right? So if I have a hypervisor vulnerability, I have to see what are the potential mitigation techniques, right? So I just showed the problem there, but now I'm showing what technique I can do to mitigate that. Obviously I can be proactive, I can use introspection scheme, I have to have some monitoring, hardening mechanism, I probably have to do some software vulnerability management procedure. These are potential ways how we prevent the attacks. The same thing in the orchestrator, right? So if so this use case is the orchestrator manipulates the configuration, and you're supposed to run one virtual network function in this location instead of putting here, puts it somewhere else. Or modifies the configuration, the YAML file, YAML files, all those, right? Right? You get the ability to install different places, but if it doesn't get installed properly in the right place, or somebody comes and hijacks the communication, then it becomes bad thing, right? You may not get the right thing. So for that also there are mitigation techniques how to do that. You can have access control, file system protection, configuration management, and you get a monitoring system, all the ATI. So I just get 2 examples of how to approach the problem. Now if I now I'll do a little quick. So now I talked about SDN NFV, telecom. Now, if you look into, I'm just giving, those pillars I showed, about 10 or so, I'm just giving some example of those now. On the RAN side, mobilize and network slicing. So let's just briefly go over that. So this is the RAN cloud I was talking about, the radio access network. So what is happening here, you see those cell sites. The cell sites will still stay there, but a lot of the control functionality are going to be in the cloud. So by doing that, what happens is you have the ability to spin up more, cloud RAN functions, things like that. But because we are trying to put the security at virtual firewall, all those stuff, also because of the edge security, they'll also stay there. And you still have the hypervisor come on hardware. So all those problems we had with hypervisor will be reflected here also. But important part is, if you have billions of Internet of Things and that's sending the some kind of attacks, you have the ability to control them right at the RAN on the edge. Right? You don't have to go all the way, in the core. But what happens is, in that case, if you keep on spinning up new virtual firewalls, you're starving the resources because you still have the same resource, right? You might starve the resources for the cloud RAN functionality because they are all using the same resources. So you may have to do some kind of a slicing or priority stuff over there. Okay. Yeah. So the next one is mobile edge cloud. So here, this is an example I showed before. So if you are providing low latency application, right, many of the security contexts will be stored here, right, in this. But by doing that, you are actually opening up the vulnerability. I mean, traditionally, what happens? You go all the way to the core of the network. So in this case, if I'm storing them here, I need to have proper mechanism to encrypt them. There will be a lot of going back and forth between edge cloud and the core, so I need to protect those guys. Then the other thing is, when I'm handing off, rapid handoff, usually I have to re-authenticate myself, right? So instead of re-authenticating all the way to the core, I re-authenticate right here. I get a temporary security association while I do the actual permanent. So I don't have the session discontinuity when I'm handing off. I have secure seamless mobility. So people are thinking about distribution, distributed service, DSS, which HSS in the core. So there are some solutions there. So the whole idea is how to protect the security context if I'm moving to the edge, right? That is the high-level challenge. So, and the third one is the slicing. So I think I talked about it, but this I'm showing here. So you have different types of application sharing the slices. By that you are sharing the resources, and each slice is separate. But think about it, one UV is connected to multiple slices. That could be potential source of attack. Since they are sharing the same resources, the slice, there's a shared memory channel attack also, one slice to another slice. Denial of service to one slice can do denial of service. They can steal the resources from other slice. So these are the potential security use cases for slicing that we are talking about. So I give 3 examples. Now what is happening in the standard space? So you have, I just gave an example of few of the standards. I think many of you know all of these. So IETF obviously defines all these protocols, like DNS and all those. So they are doing a lot of stuff in the security service sharing. 3GPP is defining the whole architecture of 3G, 4G, 5G. ETSI and NFV, I gave some examples of those security virtualization, whole Mano orchestration, everything started from there. So they have a big contribution to the whole SDN and NFV space. Within IEEE, besides 802.11, we're also doing lots of other IT specific standards in different societies, computer society, communication, vehicular technology. The idea is you're also defining new chip, new antenna, new circuits, right? So those are the ones IEEE is doing. The ONF, OPNFB, Open Daylight, OpenStack, ONOS. These are all the open source, platform, right? So if you want to build your own 5G open source network, you can just get stuff from there and do it. I mean, when I was in AT&T, I built a lot of stuff myself with my team, and it's pretty interesting, right? And even government, US government is also looking into that now. And then you have a lot of the regulatory aspects, like all ATIS, NIST, FCC, CSA.
So may I ask you a question?
Yeah.
So in the work that you're doing and that you've been briefing us today, is that gonna flow into this IEEE row here into?
Right. So I'll tell you what is IEEE role. So IEEE is playing a complementary role here. So we are defining, coming up with new technologies, which kind of 3 or 5 or 10 years. So for example, if we define a new algorithm, optimization algorithm to reduce the handover delay or add new security optimization technique, we bring it to 3GPP.
To what?
3GPP, the third generation
Oh,
partnership.
3GPP,
Yeah.
okay.
3GPP, they define the architecture. Remember the first slide I showed, like 1G, 2G, 3G, 4G. They define those MME, all those things. But IEEE has a different role. It provides the algorithm, new techniques. We don't define the architecture. Okay, we help improve the architecture, right? We help come up with new antenna, new form factor. If there is a handoff delay, a lot of things are happening. IEEE researchers, they do come up with the optimization algorithm. Then we tell it to 3GPP, look at this algorithm, you can fix this, by using this. So that is the role of IEEE. So in a way, we complement that. Because we develop technology, IEEE develops technology, not the. I mean, we don't want to call it 5G, 6G, or 7G. That is a marketing term. We come up with a new roadmap. Okay, so I will skip this. So this is a standard testbed that you can how it looks like, and this is something I built when I was in AT&T in a very high level way without getting into any vendor specific thing here. You can literally create a 5G testbed using some emulation, a little bit of Bees and all those. You can have stuff in the Amazon cloud, all the security servicing I talked about, SDN Controller, IMS. So this is like a playground of an operator network that if you are a researcher, if you're working in a school or even in your own R&D labs, students can even do that. This is very good experience to build an end-to-end network. So I just wanted to tell you that this is so important. Let me just, this is just a use case of how you detect an attack, right? Again, I did it in a lab. This example now it might be on, think about the LTE network I said, and what I'm showing is 3 different types of attacks. One is the somebody is going to a bad URL, you detect and stop it. Second one is somebody is downloading a document which is a malware. The third one is somebody is doing overload. It's not supposed to be using someone's bandwidth, and how you control that. So the one thing is showing you detect that. Okay. So you basically have those virtualized IDS, right? You have probes, you detect that, you find out which UE, which MC, which IMEI, from which location it is doing. You come back to the policy control enforcement function. This is the enforcement function. Then use some procedure to stop it, right? So this is a way of closed loop automation that I was talking about, right? And I'll show you some screenshot. So the first screenshot is, I'm using a virtual IDS, this one is conviction. And I found out, I get an alert that this guy is going to this URL which is blacklisted, so I cannot stop that traffic, right, once I detect that.
Excuse me,
Yes.
on the previous slide, did you say probes?
Yeah.
Multiple
passive
probes?
probes.
Can you
Yeah.
help me to?
Yeah. So you see that virtualized IDS? So it doesn't have to be virtualized, by the way. You see this?
There you go. Okay.
So these are like passive probes. They are almost like this is not inline. This is passive probes. You are just mirroring the traffic, right? So here, for example, this is my data plane S1U. S11 is my control plane. So by having the ability to look at this traffic, I can correlate signaling and data plane, and I can find out. And I also have IDS. I do deep packet inspection to see which UE the user endpoint, right? Is IP address, IMEI, which location, because I need to know who is the attacker, right? So whole idea is I now know the demography of the attacker, details of the attacker, then I can put the enforcement function and stop it. I think that was the idea. See, this is one of the attack the threat taxonomy I talked about, right? So going further, so this is the blacklisted, this is the malware thing. So if you see, because I have a deep packet inspection, now I can see which malware is embedded in the document, right? So I immediately know this guy is sending malware, I stop the traffic, I stop him completely. And the third one is throttling, right? Throttling is a bad term, but I see a specific user using up bandwidth which is not supposed to be using according to the policy, right? So I go and I change them, put them in a different channel, a different track, right? So I control the actual traffic flow. So this is there's some examples of how you can detect and mitigate. So so basically this is my technical talk. The end of my technical talk, I maybe spent. The roadmap document is available in the website. We are coming up with the second edition by December GloCom. It will be available. We're still working on it. So each of those working groups will have about 30-page document. So I think it'll be huge, but I'm trying to write a condensed book so that will be easy. I've been asked by Nimchan to do that. So I guess I ran over time, but just wanted to give you a little bit of technical and a little bit of future network. I'll share this slide, so feel free to
They are available.
share it with anybody. Yeah.
Did you need
I have a question.
Yes.
Are you seeing any preferences in controller protocols?
So are you talking about an SDN controller?
Yeah. Yes.
So ODL was very popular, but ONOS started late from the Open Network Foundation. But ONOS is getting, ODL is still popular overall, but ONOS is catching up.
More than OpenFlow?
I'm sorry?
More than OpenFlow?
So OpenFlow is a protocol, right?
Right.
So when you control these switches, they use OpenFlow to control that.
Okay.
So ONOS is just open source, they all use OpenFlow anyway, right? So.
Okay.
Yeah. Any other question? Yes.
Yeah, you said that 5G core is not there yet. How does that fit in the roadmap, the 5G core?
Right. Which the IEEE roadmap? Which
No,
roadmap? The
yeah,
3GPP?
In the field, in the actual implementation.
Oh yeah. So if you saw that the transition technology, right? So in the transition technology, they still have not developed all the. They have not developed all the components yet. Like there's a user plane, data plane stuff, right? So people are still. I think it's release 16 now. So people are still working on it. They haven't. The products have not come out yet. This one, right? So if you look at it, so these functions have been defined. 3GPP has defined the functions.
Right.
But companies like Nokia, Ericsson, or Huawei, or even Samsung nowadays doing core, they still do not have. See, there is a partial 5G core available. Even now in a lab or APL lab, we have a partial 5G core. Okay. It has a little bit of slicing, but it doesn't have the complete thing. So until it is, you can play in a lab, but if you really want to deploy, you have to have everything spelled out. But the core is there. So nowadays you'll see Verizon, AT&T, they're all providing just the last access, right? This non-standalone. So all these people are doing
Right.
this.
Option 3 there.
Right, option 3. So this thing is already ratified.
And then, so the cloud RAN, is that what contains the new radio?
Yeah, think about that way. New radio is really just the standard, but Cloud RAN new radio is a part of Cloud RAN. Think about that. Yeah, the CRAN, they call it CRAN.
So the cloud RAN is already being deployed?
Yeah, Cloud RAN is
functionality
being deployed. There are products on Cloud RAN. Because the whole 5G core is so big, right? You cannot just directly jump into I mean, I think what will happen is, at some point, this will happen, right? Before you go there, this will happen, right?
Mhm.
Then we finally got the LTE. Any other question?
Alright. Good job.
Alright.
Thank you very much.
Welcome, thanks. So usually, Stefano Bregni asked to take a picture. Is it possible?